Okay, so hi guys, I'm back from Confio, and first of all, really sorry for not being with you there in person, but airline made it difficult for me to get to Seoul, and this is what it is. And yeah, today we are doing something a bit different. So I would try to pre-record the whole Cosmos smart contract crash course. So it would be quite a journey, as it is quite a long window to fulfill, but we'll try. So first of all, a couple of words about the academy, basically. So with Confio we are doing this thing which we call CosmWasm Academy, and I'm pretty sure that someone told you about it, but one of the course we are delivering is smart contract course. And what we are doing here today, it would be basically rushing through the course. We would cover most of materials I have prepared there to teach you about how to create smart contracts, like, you know, the difficult way. So let's start with a bit of introduction, really couple words, what we are doing here. So we are building a smart contract based systems, and to make it simple, there would be only two contracts, but we want it to be a bit more difficult than a single one, so we can talk about things like communication. And here are the contracts. So we would have donation peer and donation manager contracts. The whole system would be a donation system. So how it works? Let's say we have some creators who want to join their forces and maybe, you know, have a common donation system. So donators of every one of those creators can donate, and every creator in the pool would benefit of that. And depending how much donations the single creator receives, his contribution in the contribution to the rewards from the donations is basically growing. So how much you get from donations made by donators would be linear to your contribution to donations, basically. Okay, by the way, this whole repo is public. It is on hashed1 CW workshop. It is my private GitHub. It should be available forever, but it may migrate to CosmWasm on Confio repository. We will see. It is as I was kind of in the rush to, you know, reshape the presentation. And so yeah. Here are those contracts: donation manager, donation peer. You can take a look. Here we would not implement them like fully. We would try to talk about the most important techniques, the most important parts, and some of those simple things which are tedious, I would just leave for you to maybe do it yourself, or you can just skip it, because, you know, we have only 2 hours for that. Yeah. So the peer contract is a very smart contract which just holds money the particular creator gets from donations. So basically, single creator has a single peer contract. That's the idea. And also this peer contract would contain this counter, how many donations particular creator gets. So how many donations was performed via this very peer. So it counts for increasing this creator contribution to the poll. And there are two functions here. Donate function is one called by the donator. If someone would like to make a donation to the pool, but incrementing this owner of this contract, contribution, he calls donate on the peer contract. The whiteout function would be called by the owner of the contract to whiteout funds. And the other contract would be manager contract. And what is a manager contract? It would be contract aggregating peers. So it would create those. When someone joins the pool, he calls the join on the manager contract, and it would create peer for him. Worth noting that in this very design, anyone can join to the pool. So I mean, maybe it's not something you would like to do in real life, as basically creators on this pool may not accept someone from the outside, but this is something to consider. We are going simple here, so someone can just join the pool, someone can leave the pool, and someone can donate. So this donate is actually to be called only by the peers. You cannot donate directly via the manager contract. It's something which should be just rejected. Technically, there is a way you can just send funds there, and they will be distributed later via the distribution message, or maybe we can avoid it. We'll see in a second. But in general, the idea is that this donate function is called by peer when donation is happening. And yeah, let's see what flows we are actually implementing. We are implementing the very simple. This is the join flow. So when someone wants to join the pool, he calls the join method on manager. Manager instantiates peer with some config. We'll see it while implementing what is actually configured. And then the instantiate message would return the address of newly created peer to the manager. And manager then needs to register peer in internal memory, so it can. It is important for 2 reasons. So no one can join twice. When joining, I actually didn't show it here, but when you join, call would fail if you have already registered pool. Yeah, so we'll try to implement that thing. And also when we are distributing funds, then we need some iterable, so some pool we know we should distribute to. So this would be this thing when we register peer, and also we would use it when we would check if donate function is called from proper place. So yeah, this is the join flow. There's leave flow, which is basically very trivial. It just removes the peer from the pool, from the storage, from this pool basically. And we do not destroy contracts. There's no notion of destroying contract or so. So this peer contract is staying on the blockchain forever basically. But donating through this would actually never work, because it would not be allowed to call a donate function anymore on the manager. So basically this peer would be alive, and someone, if there are any funds left, someone can withdraw them still, but it's never more useful for donating. So leaving one is very trivial. I think I would not even implement this here, but worth keeping in mind that there's this thing. And yeah, this is the clue, the donation flow, and let me enlarge it a bit. So how donating works? So first of all, donator call donate on some peer, so peer contract. Yeah, I omitted some things here, but I will talk about them. Okay, so donate functions. Now peer just sends donate with funds, but times some collective ratio. Why is that? So there's this idea here, maybe smart, maybe not, that when you are donating to the peer, some funds are sent directly to that peer, and only some collective ratio of those funds are sent to be distributed to everyone. So it's kind of maybe to promote small creators. So if you donate to small creator, he still gets some of the funds you send him. So it's not like he will never get anything from donations. Yeah. So yeah. Then when you send this, and what's very important, funds we do not send here are left on the peer contract, basically. Yeah. So yeah. Now the manager would query every peer which is registered. Here in example I have only 3 peers just to make it easy. Query for how many donators are there, so what is your weight, right here. And everyone answers with donators count or donations count, doesn't matter exactly what is it. And here can ask a question, so if it's this way, then peer can actually lie, right? And yeah, technically, maybe, but there is very important thing. Let's go back to the join thing. This is exactly why we do not let creator to create his own peer, but manager creates the peer. So what is the consequence of that? So because of that, manager exactly know what is the implementation of peer he creates. So he can trust that this peer would not lie to him because manager knows the code the peer is created from. And because of that, peer would never lie to manager because manager know how it's implemented. So this is why we don't want creator to create his peer. There's the idea of this manager. And then when manager collects all those donations count, he would calculate total donators and basically send funds to every peer basing on funds. I mean, it would be even possible, for example, not to ignore this peer for this calculation, assuming he got some from correct ratio. But let's keep this way because this is how it's designed at first place. And obviously here what I told you I missed thing, I didn't note that this peer here, probably before donation, so here, it would increment his donators count. So it would happen in this donate flow. I completely forgot about that. Anyway, this is how donate would work. Obviously, you can argue that it's pointless why we do not keep this donators counter directly on the manager contract, and why we even have those peer stuff. And he would be right. I mean, it's way more better to create this very simple design in simple contract. It would be more efficient. There is a thing I would like to teach you how the contracts talk to each other. So this is very artificial, that's true, but do not bother. It's just for, presentation purposes. Okay, and there is another last flow to be implemented, which is wider flow. We'll see if we'll go to that depending on the time. But it is, when creator wants his funds back, he calls peer, and peer would send all funds it gets from outside to send them to creator, right? So this is the last flow. But yeah, this is the design. This is the design. And before we start, I want to give you a very brief introduction about how contracts are talking to each other on the design level. So what is an actor model, how it works here. So yeah, you can read this wall of text I wrote to explain it, but right now I would just quickly go through this diagram. So smart contracts are designed to work in the actor model I mentioned before. And what does it mean? It basically means that there is like no direct communication between them. So you can imagine that when contract gets something to be done, it just needs to do this from the beginning to the end, and it cannot be interrupted. It cannot like schedule part of something and do it in between. So basically on the very, very atomic level, the whole execution is like atomic, yeah. But it brings problems. And yeah, first of all, to make things easier, it does not work this way for queries, because queries do not affect contract state. So queries cannot change anything in the blockchain. They only give you some response, yeah. Because of that, queries can be actually sent in between the contract execution. Yeah, so why I am handling, for example, I don't know, this white draw thing, I can query the bank, which is like, you can think it about built-in contract, but it's basically the blockchain, it's implemented in blockchain. But you can query something, or like here, you can query different contract while the execution happens, without breaking the execution. This is the first thing. But it's still kind of lacking some features, because if that's how I explained right now, it would be impossible to, for example, do some job, then schedule some other things to do for the contract and finish my things later when the other contract did its job. So it's impossible in terms of those atomic operations, but we developed a way for that. So let's see this very detailed flow very detailed. It's still simplified, but it's this flow of execution. We have a couple actors here. So the first one is sender. And who is sender? It's basically someone who triggered the operation. It would be some web page, it would be some node, it would be yourself, scheduling operation, right, on blockchain. Blockchain is, and what I mean about blockchain, this is basically the executor. This is the virtual machine executing the smart contracts code and doing all those magic, this hashing, everything related to blockchain and making it work. And those are contracts. Those are smart contracts which does some job. We don't know. I am not going into what those contracts are. And so sender wants to execute some message. So what it does, it's kind of important to think about it this way sometimes, that it just sends the exact message to the blockchain, and as parameters, it sends address of the contract to be executed and the message to be sent. Yeah, I know those are not proper JSONs because of these sticks, but I want to make it simple here. Okay. So we schedule execution. One thing, there can be more fields here, and one important one is funds. So with every execution message or instantiating message or migrate message, whatever non-query message, you can send funds with. So those funds are basically those are native tokens which are transferred from your account to the contract itself, because contract has its own balance as it has its own address. Yeah, that's and I would not describe fund sending on this diagram. We would do fund sending in the contract implementation. So we are sending this execution. So what blockchain does, it executes the contract one with the message one. Yeah, that's very simple. Yeah, we are executing. Message one handles the message, and during this handling, it could query something on contract 2, contract 3, or maybe on blockchain itself, for example, you could query bank, which is contract itself, or whatever. But our message one handler, instead of sending the final result, it could actually send the execution schedules, orders. Okay, so execution orders. And what's very important, after it sends something back, this handler may never resume. Those stuff are sent after this message one handler. Yeah, it could contain another thing. You could send back some data. So we are not going into details, but very important thing. When you send something back from the handler, your handler is done. And here we scheduled some free executions. We scheduled some 2 executions, message 2 and message 3 on contract 2. And we scheduled execution on contract 3, but note that we scheduled those executions in blockchain. We are not executing them yet directly. And note that our message here, it's activated. What I mean by that is, as long as those executions are not finished, the message 1 execution is not considered finished. Our handler is finished, but message 1 execution processing is still ongoing, and this is basically handled by blockchain itself. Yeah. So now what happens? Blockchain is executing the first message to be executed for this handler, and this is contract 2 with message 2. So this execution is scheduled. Yeah, this message 2 on contract 2. And message 2 handler does his job. It just sends response. Yeah. So in this example, everything succeeds. I mean, I do not go into error handling. I would give you a word about error handling in a second, but I don't want mess on the diagram. So yeah. Message 2, response sent. So what happens now? So message 2 is finished. You can see that it's never more active. Message 3. And see here, I gave that reply on success. So what does it mean? If the message 3 handling by contract 2 to succeed, then send me response to handle. So do not assume the execution is done, but trigger me, because I have stuff to do after this message 3 is succeeded. Yeah, but only on success. On failure, just break the execution, it fails. Yeah. On success, I want to do more processing, and I send you this ID. And this is, you'll see exactly why it's ID is sent, but basically it is an identifier for this message, because when the reply would be sent to the contract 1 for handling, it would not contain either this message or contract sending the reply. Yeah, you will only get this message, this ID you send with the execution. But you send this ID only if you want to handle reply, because the only purpose of the field is to match the reply to the message. Okay, now execution. Nice. So it's message 3 execution. Yeah. So when message 2 response is sent, then blockchain remembers that we wanted on success wanted to handle the reply. So reply is sent. Reply, and it contains only this ID, which is ID we sent here. And based on that, we need to match what reply was sent. And you see here, I created this double activation thing, because the original message is still processed, but here we are processing like reply for message 2. Yeah, here is this handler for message 2, and what we do in reply, very important, reply is normal message, and we can schedule another execution. So we scheduled message 5 on contract 3, and what happens is that when this is scheduled, before we would continue handling those 3 messages, we need to finalize handling message 3, right? And we cannot finalize handling message 3 until the reply for it is not finished, right? So because of that, here, blockchain, instead of executing this message 4, he needs to first execute message 5 on contract 3, right? Message 5 is executed, response is sent, and while the response is sent, then this reply is considered done, and then this message 3 handler, message 3 execution is considered done. I think this activation should actually go a bit longer. It's my fault, but yeah. And now we have this message 3 considered being being finished, processed. So what we do, we continue handling message 1 executions. There's message 4 left. Yeah, we send message 4 to contact 3, and this would be no surprise for you, I hope, that this execution of message 4 can schedule another execution here for contact 2, right? So what would blockchain do? Yeah, this is still processed because we first need this contract 2 to be handled properly. Yeah, by this message 3 for contract 2 to be handled. So this is how we communicate. To have this multi-stage processing, we always need to send message, and if we want to do something when the message is done, or we can have this ID to match the message sent to what I sent, to what reply I received. And only when all the messages are handled, I get the response, and at the end, the sender gets the whole execution log from the blockchain. Yeah. Now a word about succeeding and failing messages. So here I assume that all messages passed. But what's very, very important is that every execution is transactional. So what does it mean? Either whole message succeeds or nothing happens. So for example, here there's message 1. If any of those execution fails, then anything happening in this handler is discarded. How it's implemented is that this message handler is not operating on the blockchain state, it's operating on the blockchain cache, and this cache is applied when the response is called. And here another cache is created, but this another cache is applied to the first one. It's like a stack of caches. It's applied to this call cache when the response is done. So this is like layered cache, and the final layer is applied to blockchain when the whole execution is passed. But very important, here execution, we do not expect reply never. So if the message to execution succeeds, the message is considered succeed. Here this is similar, but not exactly so. If this execution of message 3 on contact 2 would fail, the whole handling would fail and nothing is stored on blockchain. Yeah, the execution is interrupted. But on success, this reply handler is called, and we can fail on this reply handler. That's very important. That here we can fail, and if this reply handler fails, then whole execution fails. But besides that, we can also get reply always, so both on success and on failure, or even only on failure. So why that's important? That means that even if this execution message fails, reply for it is called. And if this reply, this reply would pass, would succeed, then the whole message tree is considered succeeding. So using this reply always or reply on failure, you can actually overwrite the failure of the message. For example, if it's not relevant for you for this message to pass, it's like only side effect you want to achieve. Yeah. So those are those messages, and this is how the actor model works. Okay, so we are somewhere around half an hour right now, and we should start coding. So starting now, it would be basically hands-on code. I would try to comment what I'm doing. I would rush a bit, but would try to keep the tempo so you can understand things. And I would try implement most important stuff. I would less focus on easy stuff on like, for example, withdraw or leaving. Okay, here I opened Doctor's Arrest, and this is something I want you to be like friends with. We would like to always have Cosmos stud opened, probably CW storage plus is something you would always have access to documentation to. Also, if you would go to test, I have no idea if you would be able to do some testing, but there is the multi-test crate, and this is something you also want to take a look at. You for sure would use the CW utils. I hope you would make that. Yeah, so those are crates. You want them to be around. I would keep them on another monitor. And also, because I don't want to get lost, I have the implementation open on my other screen. So if you see me, lurking somewhere on the side, I'm probably checking what I was thinking there. So let's go to, I created this fresh directory. It's empty. Let's check. Yeah. And here you'd create some cargo Tom. Yeah, we are not going with creating the cargo project right now because we have two projects actually, and I would start creating a workspace. For now, it has no members. Okay, but with cargo build, it should tell me there's no package, but there is. It's working. Okay, so let's start with our first contract, and it would be let's say cargo library, and it would be we will start with peer contract. Now what I do, I modify cargo TOML, and I would add a peer contract. Let me build it. Works. So let's go. What do we have? Not this contract, I guess. Yeah, this one. Let's start defining some API here. So what I have here. First of all, being here, I need to here. I would like to create a message module. Yeah, message res. And here what we are doing, we are cargo first. First of all, we need some dependencies. It would be like CosmWasm stood. CosmWasm stood. It would be we would need CW storage plus. I believe it's 13.4. Yeah, actually you want to go. Oh, semantically better. I would use CW utils. Would be also, I guess, CW. Yeah, this would be the version I want. I need Serda. I want it with derive. Let me check if there's something else I need. I don't think so. No, that's all. But that's not everything in the cargo TOM. First of all, to create my smart contracts, I need another crate type, and it would be CDY library, which is dynamic library. I want also a library because I would use this one as a dependency. Okay. As I want to add a feature, and what is that for? So when we would create a contract, we would create endpoints for the contract. There is a point thing. Every contract can have only one set of endpoints. But when we would use this peer contract as a dependency in the manager contract, we don't want to import entry point from it because the manager contract has its own entry points, and because they are unmangled, we cannot work around that. So what do? Is typically create the feature flag which we enable it only when we import something as a dependency. So we are doing like a set with this feature flag here. And in the contract itself, I would disable generating entry points when the feature flag is up. Okay, so we have dependencies. Let's go create API for the contract. So yeah, start with instantiate message. So we'll create we need a way to create a contract, and this is something which would be called by the manager contract. It's instantiate. Yeah, so copilot would sometimes do some strange things here. We need owner, and owner is an address of who can withdraw money from this contract, basically. Not who created it, it is who is withdrawing money. I would actually add the incremental donation. So what is that? It is basically why? Okay, I think I know what I did wrong. Go to the library of message. Why I don't get syntax? Use. Okay, for some reason. Okay, sorry for that. I would just shut down Slack. So I'm coin right now. For some reason I didn't get it here, but so what is coin? Coin is basically type which contains two things. I know what happens. Extract. It contains two things. First of all, it's a denominator of the coins we are sending. So some name of the token we are sending, native token, and the amount is how much tokens we are sending. And why do I have this field? So basically, this is utilities to check the minimal donation which is needed to increment the counter. So someone cannot send, tokens, single token by single tokens 100 times just to infinitely increment tokens for increment the weight of the here. And another thing we need here is this collective donation thing. So it's how much of the donation goes to the collective manager contract, yeah, and how much is left. So it would be decimal, and decimal is decimal type. So this is instantiate thing. Let's go to the execute message. Oh, first of all, we need to direct some stuff. We need serialize here from Zelda. We need deserialize. Okay, basically we also need clone, debug, partial EQ, which are a bit optional, but we really want those. Yep. So now, not direct Zelda. Now, execute message. Here, we want yet another thing. We want set rename all but to same case. And I would not go into details. Why do we want this? We just want this, and just go to set documentation, check how it works. We want this on every single message we are implementing. And now we are going for execution message. It would be enum, and we want 2 of those. Donate. And as you can see, I am leaving those curly braces, and really do not omit those on your messages. And this is because it would affect how SAD is serializing messages. Again, this is very, very sad thing. For messages, for things you are serializing, you really want to leave those curly braces here. Another thing, and the last one would be query message. Almost last one. And for now, I am going only for one query message, which would be donators. And this message would be this thing which queries how many times this peer was triggered to donate. So now last thing we need response for this message with send structure. And it should be, it would return how many donators we have. So yeah, here we have our API defined. We'll work on it in a second. And what now? Let's say we would want work on the state. So every contract to work, it needs some internal state, and we also typically put it in separate module. So let me open it for a second, but yeah, we would need two states variables in our contract, and one of those would be the owner of the contract. When you define our state, we just define accessors to it, because state is stored in blockchain. You would have the depth argument and entry points. You will see it in a while, which allows you to access the state. But in the end, you would like to use some nice API to work on the state, and those accessors you are creating, they are constant because they are just created to reach those data inside, but there are no data stored in those. Yeah, and what is this owner for? It is to check if someone can white draw, and this is basically when we use it to check if someone may white draw. Once I create a new item here. Okay. Okay, it's never used. That's why it's used for me. And there's another thing we would like to have here, and it would be a custom structure. So to use something state, we also need it to be serializable, because state is basically kept on the blockchain as JSONs. Oh, okay, and it almost read my mind. So it should not be owner, it should be manager, probably. No, it should be, yeah, manager. So we need the address to the contract, which manages donations, so we know where to forward our donations. And we need to store somewhere our information about incremental donations, collective donations. We also want to keep our donators count. And here is very see, there's this problem when Copilot helps me with something, it doesn't fulfill the use statements. Anyway, so there's an interesting question you can think of, that why I like state. I want those to be unique. So why some of state like owner I keep in separate place, and some of those we keep in a structure. What is this thing? There are two things you pay for when you are accessing the state. First of all, is basically accessing the state has its cost, and it's kind of constant cost. And then you have another thing, which is how much data you are transferring. So either storing or reading. And there's the thing. When you are using the state, you most probably use for the whole state in our contract. I know it because I know how to implement it, but basically sometimes we are shuffling around stuff. There's an argument why to keep donators in separate variable. So we can do that actually, because why not? We would do this like const donators item. And why to do that is when storing something on state, now we send just single U64 instead of those whole state. And we would even rename it to config. Because of why not, yeah. It may be a better way. Sure. But whenever we would use this config stuff, we would probably use whole of that, and we would use it on donate place. But that's not true about owner, because when you use owner, we probably do not use config. We use it mostly to verify the ownership of the contract. Why verify it? Okay, so this is a state, and let's go to my library to make wireframe for this to make to create entry points of contract. And let's start creating 3 entry points, and those would be functions like normal functions. Start with instantiate. Public function instantiate. We need 3 arguments here. I would, for example, for now I do this like this. First argument is depth_mut, and this is how we either send response to the blockchain, but also how we schedule new executions on the blockchain. We are also depth is something we are using to query another contracts and to affect the state. So this is the how we manage the blockchain state. Basically, we can query for it, we can store there. So we are using depth for it, and it is depth_mut in this case because instantiate can modify the contract state. Another thing is, I think it's right now I'm not sure about the order, so let me double check. But yeah, second one is env, which is of type env. And what is that? This is blockchain state. If you jump to this, it is how many blocks we have there, some transaction info, which is do not bother about this, and this is as our contract information, basically our contract address, so we can know address of ourselves when we are executed here. So this is environment. Then we have info. Let me move to another line with message info type. So what is that? This is meta information about message. So every message, you know who exactly sent this, and it's not something you cannot claim you are someone else. This is verified in the blockchain that you got this message from this address, and you can send some funds with the message. So this is why we have this funds here. You do not have those funds on the message itself. It's sent and verified by blockchain. Here. So this is message info, and the last argument here is the message itself. So here to the message, I like actually not to import them, just do message instantiate. And that's all. And now the return type, we would go with stud result. I am not going into any error handling in this workshop. No, we are in most cases we are using this error, but I want to keep it simple and just ignore that. We would use stud result as this is basically Okay, I didn't get that. This is to results. It is an alias for core result type with std error there. And what is std error? This is the error type you would get from the standard library, from CosmWasm std. It would be a problem for us because it's not what would CW utils return, but we would work this around when we need it. Okay, so we have result, but what is the okay case? It's a response type. And response type is a type to give communicate back with the blockchain. You would set the execution result here, but also you would add any executions you want to schedule and the message you want to schedule as to suggest for this message. So if we go back to this diagram, sorry, I closed it with me. So yeah, those messages here, this is set on the response message, so on the response type here. Now other things you can set here, some attributes, events, data. We do not bother about that too much right now. We just return this for now. We do. I just want, you know, a frame for that. What I need to do, I need to create entry point, and basically what you do is this. But as I said, you need to import this. As I said, you don't want to generate those entry points when you are built with this feature flag. So there are two ways to do that, and I would show you both of those. Here on the Spirit contract, I would just do the more common one. The one I like less, but it is more common and you probably will see it everywhere. We use config attribute. Just let me double check to not miswrite it. Config attribute not feature is library. So how it works is this config attribute is a macro which would set this attribute, but only if the condition is true. So if it's not built to feature library, then set this entry point here. So this function is okay to be exported in binary. What we don't want to generate entry point out of that. And entry point is unmangled wrapper for this function to communicate with CosmWasm, basically magic generated by entry point. I can even show you that. Let's go entry point. I hope I should be able to show that. Code. So yeah, let's actually close this for a second. So what is generated here is this is our function, and next to it we have generated some no mangle instantiate with some magic happening here. So, and it is only generated for WASM actually, but yeah, that's all okay. Right, so close that thing. We wanted to generate it only on library, and yeah, this is on instantiate. Then now let me copy that thing and create an execute entry point. Execute. So instantiate is basically constructor. Yeah, this is how it's called only once when the contract is first time created, and this would be called by a manager contract while period created. Execute is called when execute message is received. So here it would be very much the same thing, except here we want the exec message. Show me message. Okay. And last one is query. And query is a bit different. First of all, we do not have message info. We cannot rely on message info in queries. We cannot send any funds in queries. We cannot alter a blockchain state in any way. We cannot restrict query to, I don't know, sender. We cannot depend on that. And because we cannot change the blockchain state, depth is becoming depth instead of depth mute. Right, and now another difference, result of the query is not some response because it do not participate in the typical actor model flow. Instead, we return something called binary, and binary is arbitrary base 64 encoded data. Here it would be just JSON, which is encoded, and this is JSON, which is response sent to them, whoever queried. Okay, so now we will not go into implementation of this contract, I think, or maybe let's start with a very simple thing, just as a warm-up. We cannot implement donation just yet because we need this donation part from manager contract, but maybe let's start with implementing the query. Why not? So what I would do typically, I would create another module, which would be contract. And here in this contract module, I would create another submodule query for query handlers. And what I need here is this. And this is how it would look like, except I need depth here. Not okay. Yes. No, I do not get hints here, but doesn't matter. So, oh, and we need to implement instantiate actually here. So, so what do we do here? We need to use our donators. For some reason, I don't get syntax. Create. Here I need only donators. Create. Oh, states. How do I typically call it? Because right now I'm stupid. If it's storage or state. Yeah, it's state. What do I do here? I do not want to return U64. I want to return my donators. I mean, that won't be open because I think I should get. Yeah, I should get this. And I want is to the result also. What do? I do my donators dot, I think it's called out. Would it be always there? Yeah, it would be always there. And I need to pass the depth storage. And it can fail. Right? And what I do is let's. Okay, that's fine. Load may fail. And load may fail in many cases. One of those is when there is nothing in the storage. if there is a case when you expect some that there may be nothing stored yet because you didn't instantiate it or something, you can call the mail. But you'll make sure that there's always something in this donators, so we just load it, but what we need to forward the error. And now I just do think it should be all fine. Yeah, it's all fine. Let's go back to the query message. What I would do here, I would just do use message query. I would just import all variants here. I would obviously get rid of this. I would get rid of this, and I would match on my message. In case of donators, I would probably also use a contract where like this. So, well, I'll format this way. Something is wrong here. Okay, so here my donators return some donator response, but from query I want to return a binary, right? So we need to work on that. First of all, if the space we face, and what we do here, we go to binary from standard library. Data is a borrow to something. That's good. Okay, it doesn't like something. Okay, because I used exec here, should be query. Okay, so this is a query message, simple. Instantiate message. We need this to implement, joining at the first place. So what do we do here? We go with, I don't know. First, we need, actually, what I would do, I would implement it here. Do not have any logic in my entry points. On entry points, I typically do only the dispatching thing. Just to have some order, it is more like, my liking, not very relevant here, but I would have function instantiate. What I would have here, I would for sure need depths, which would be depth mute. Do I need my environment? I need my environment. No, I do not need an environment. I would need message info. Why is that? Because I need to store the manager contract address, and the manager contract address would be the one who sent the message, right? So it cannot be fake or something. So it would be message info here. Yeah, as you can see, Copilot is trolling me a bit. And there is the message. So for instantiate, I would just take the instantiate message here. Because of why not? I need response. And what do I do here? Okay. First of all, I need to create my state. So let my config. My config is config. Okay, let's do it this way so I can check what fields are missing. Or even just open it here. Config. So manager. Who is manager? I can find it in message info. Sender. I store my sender as an address, so I always know its valid address by the type system. Okay, incremental donation. This is just a message incremental donation. Same for collective donation. Yeah, message. Nice, nice and easy. We can store our config. Just save. That's storage. Data would be config. see. I could actually do this like this. It doesn't matter too much. Yeah, it's nicely formatted. So okay, now donators. Very important thing to, as you don't want to, you know, always check if it's instantiated. We just instantiate it with something, and probably we want to instantiate it actually with 1, not with 0. So I always get some. Oh no, it's 0. So if I even joined, unless I provide something to the pool, then I do not get any rewards. That makes sense, I think, to me at least. Yeah, it complains for on error type probably. And now owner. We take owner from the message. There is a problem here. If I would do this, it would not compile. Why it would not compile? Because yeah, we have string. We want owner to be verified address, so we need to verify it. I would do depths dot API, and it's valid address validate function. So we do this. We take this. Doesn't work. Okay, address validate can fail. Yeah, everything works. Okay, and now we want to send some response because, as we told before, even in instantiation, we could schedule some additional work to do. So what we would send response default in this case. Okay, now instantiate is never used. We can work on that easily. Instantiate here. We would do contract instantiate. As we are using those guys, I would just undash them, like, you know, just my PTSD. Oh, oh, I want info, not env. End message. Nice. And this is actually most of our contract. We do not have execute. What I would do here is I would prepare dispatching. So just to have dispatching done, I would do this like here. I would have match on this and here. I would return, but I would not return. I would return error. And it would be generic error. I can use string here, and it would be for now, you know, I don't know how much we would do so. Font move message. Yeah. So let's go to the more interesting contract, which is the memory contract. So we are here. First, let's build this. Okay, quickly. It's like sometimes my Vim is taking over the analyzer. So let's build this thing. Yeah, I would also build the WASM target quickly. Cargo built, but target would be unknown. And yeah, I'm doing this. I could alias this comment. I would even show this. So I would often have this thing that I would create a, where am I? Cargo.config. Sorry, .cargo config file, and here I would have an alias section with WASM being built with So I would do this in very particular reason. So now I can just call CosmWasm. In my contract, it's not in the alias is working only for the place I created it, so for the contract here. And the WASM target is built, it's kind of easier than passing this. And why I want to build the WASM is I would have it target. I would use the check contract quickly on the first maybe let's find. So we have some outputs for the contract, and I would call check contract. It would be pure WASM. So this check contract tool I'm using is helpful to check if the contract is ready to be uploaded to CosmWasm blockchain. If it's basically valid contract, and yeah, it is something you probably don't have on your machine if you never did smart contracts. So if you want to know how to install it, I recommend go to the book CosmWasm. I mean, this is something I wrote to as an introduction to blockchain. I mean, yeah, it's a good thing to read. Here is a setting up environment section, and here is the check contract utility. You want it to be installed. If you want to build smart contracts, it's easier than using that every time trying to upload something to blockchain. Also, you also need to remember to have this WASM target installed. Okay. So just go to book.cosmwasm.com, and there is the setting up environment section you may want to use. Okay, so let's go back to the smart contract. Okay, so it's time for another thing, which would be the manager contract. So go new manager. Yeah, and first of all, go to cargo from here and add it to the workspace as it is in the workspace. That's good. And we quickly go to cargo toml and to manager cargo toml. Basically do that. Right? I think so. I think it's very difference here. I want also to include the key contract here. So it would have version this. Features would be library. And I guess path. So I included, but I included from the path, not. I think I can even do that. So it's using this workspace. Complaining for something. Do I need it like this? Probably. Is it the thing? Oh, yeah. I'm modifying the wrong. Let me. Okay, it went like crazy. Let me reopen that. So we modified the peer cargo toml instead of the proper cargo toml. And here I want path to be like this. Show me here. Do I want here to be here, really? Yeah, so that now it works. Okay, so let's go again. Manage contracts message. I want to open the API I prepared. Do not get lost. Again. Where am I? Okay, proper place. So now go to message, to source message. What do I want here? I want instantiate message. And here I want, first of all, I want the peer code ID. So when to use our smart contract code, we need to upload the code, so that was binary, to the blockchain first. And when we upload it to the blockchain, it's not yet a smart contract. It is just a code. And to make it to smart contract, we need to instantiate it. So we need to send this instantiate message. And we are sending this instantiate message with the code ID we are using with this instantiate, if that makes sense. And this creates new contract with an address which is, strongly connected to this code ID in the future. But here, the manager contract needs this peer code ID to know how to instantiate peers. Also, we need this incremental donation. It would basically forward it to contract it creates, and collective ratio for decimal. Yeah, that should work. For us. And now, get message. And now. Okay, nice, nice. Now, execution message seems reasonable. Oh, I got only one line. So what do I have? I can join. I can leave. I can donate. And the last one. Query. Do I want to implement any queries for now? I think no. What would be very helpful is to be able to query the contract for the peer donation, peer contract for the address, so someone can check how to donate the first creator. But let's say that it is not like necessary. Right now we would just return the created contract address as an attribute to the caller, and he would know who created contract probably. Yeah, and if someone wants, I mean, it's good exercise to create these queries, but we will minimize our work for today. So yeah, I have join, leave, donate, and we will start with the state again. Yeah, so I would remote state. What state do we need? Oh, I think we need. Yeah, that's what I thought. So we need some this. We need structure config. So here we would have things we would have basically the instantiate message. Sometimes we need the instantiate structure here, so we just copy store the instantiate message we sent. I actually like to have those distinguished, so maybe if something could be either not stored later or will be calculated on instantiation, put in config, it is easier to maintain those two being separated structures, at least in my opinion, right? So yeah, we have this config. We need this to be stored. It's simple. It's item edit config. That's it. Now we need some members list, and it would go like this. It is map from CW storage, and it would be address, and no, to not forget, it is address. Here address to owner address. And why it's done this way, I let me finish this line first. So why is done this? I mean, it looks a bit strange to map peer contract to address instead of the other way, but that's the reason. So most cases we would use this map is this scenario when we are going through every peer, we need to iterate through keys of a peer, and we would send message. That's phone's message. And it's very rare case when we want to actually iterate over addresses, owner addresses. The only case we want to check something basic on owner address, I mean, there are two cases basically. One of them is when you want, sorry, am I right? That's the better way. Yeah, because I also want this open way when some contract sends donates to me. I want to check if there is a key for him. If I would have this owner address to peer address mapping, then to check if there is such a peer address in this map, I would need to iterate through whole thing just to check if there is the concrete peer there. And it would be waste of gas for every donation, and I assume donation is something happens often. Right now this situation happens when we want to join the pool, because while joining we need to check if this address is already there. But I would ignore that because I assume it is first of all rare case to join the pool, and second of all it is also the one who is joining, like he really wants to join the pool to get rewards later. So I mean, he can pay a bit for that, but why donators should pay for making donations? We want to minimize this cost. The best thing to do here is actually using another thing, which is called it is called multi-index map. This one, I think. So in CW Storage Plus, there's this multi-index thing. So it is the map. It's like map, but it allows to use another indices. It creates this in between hash table. but I don't want to use it because it's a bit more complicated. I encourage you to go to the documentation, to go through examples, and try to use this in such scenarios, but not for today. I mean, I am keeping it kind of simple. I really want to do the communication between contracts thing. Okay, and the last thing I have here is something I don't really need, but I want. No, sorry, I really need it. So it is pending instantiation. And it's so what is this thing? So what happens when someone sends me the join message? We'll see why we implement it in a second, but let's get a brief think about that. We want to send the instantiate message with this code, peer code ID, and we are setting the new peer contract up. And then we get this reply from the blockchain that message is succeeded, and this is your reply ID. But you will never get like the original message was said to you. You'd get the reply message, so you would get back the new address of freshly created contract. That is something you would get, but you will not get the owner address. You will not have a way to get that. So you need to store this owner address on the site, and when you process the reply, you would just check. And because there is this thing that everything is like single threaded and single processed, and you have these caches and stuff, you are basically guaranteed that unless this instantiated message is fully processed, nothing else happens from your perspective. So you can be sure that when reply is called, this is reply for this very instantiated message. And if something would be wrong, or would go wrong, and there would be an error, and the reply would never be called, also this pending instantiation thing would never be stored on the final blockchain. That's very important. It's kind of tricky to think about, but it's very important. So to make it more reasonable to think about, let's go to library, create a module named contract, and let's work on join message. Why not? Okay, this is tricky, so let me reopen it, not mess up. So we are creating this join, and what do we need here? We need depths because we would affect the blockchain state, and we need info because we need owner for our contract, and we would respond with results. Right, so what do we need? First of all, as I said, we need to store the one who sent message. So this is someone who we are instantiating right now. So what we are doing, we are using this pending instantiated, we are storing their value, which is for later usage by reply handler. And here, I saw info, I guess. I don't want this error, so I just silence the error. Right. Now what I think I need my config, because I need to forward the config while instantiation, right? So let config Now I need to prepare my instantiation message. So I would import use here, I guess, instant peer. Oh, sorry for that. I need to go to my peer for a second because I need my messages module to be public, right? And now I have my and I need my instance, but I would call it peer instantiate. Like, so what I do now is I create message like let message here instantiate it lies. I don't want those stuff here. I need those guys for sure. What did that complaining on? Let me quickly, you know, I could probably use some very quick key bind, which I actually forgot. It completely doesn't matter. I hope it works. Should get errors would come correct. Okay, so let's go back here. This works, and now it's probably not collective ratio. What fields are we missing? Collective donation. And what else do we need here? Owner. We need owner. And who is owner? Owner is sender, right? Yeah, whoever sent this is an owner. We want an owner is probably a string. Yeah, so we want to go to string with that. Okay, we have a message, but this is the message you want to send to the contract we're creating. But to the blockchain, we actually send what is called the WASM message. So let's create message ping WASM message instantiate. And instantiate contains a couple fields. Let's go one by one. Admin, I think it's an option. Yeah, it's an option. We don't want him. He's needed only for migrations. We would not touch migrations today. Code ID. So code ID we use for this sensation, and we have it from the config. Here, code ID. Now the message we are sending. It would be message. We'll come back to it in a second. Funds we are sending. We do not send any funds actually. And label is just, we can do some Greek. Let's say here it would be, it is just for diagnostics, I would say. For wait, funds is probably vector, not this thing. Yeah, because it's owned, so it's new. And here I have mismatch type because my message, I mean, it has to just be just binary thing, but we know how to go from message to binary. We just use two binary function message borrowed, and it makes it. Yeah, so this is message we need to send to blockchain. So how do we do that? Do we anything besides that? No. Instantiate. So what do? We need create response. And what I would do, I would create new response. And I need to add a sub message. And it's just a message, but it's not just a message. Because if it would be just a message, it would just be sent, and we would never be able to have a reply. So what I actually need, I need a sub message reply on succeed. So what happens? I need to send message, right? And I need an ID. So I would create some constant here. Yeah, constant. It would be here instantiate ID. It would be 4, and it would be, I don't know, 1 for example. It doesn't really matter. So it would be always this thing. Okay. It complains that it cannot figure out the type, but we do not care about that, because when you would return it from function, it would figure out what is an actual response type, because response is a generic type. There's one thing I would like to add here, add attribute. So whenever we perform execution, it's a good idea to, log stuff about it. And here we just log that action was performed. It is the join action. I can even add attribute about the sender. Any meta information I would like to keep, I would just add as attribute. It would be just it is just for logging purposes mostly. It would be sent to what's wrong? Oh, it would be info. It's mostly for logging purposes, and it would be sent to all those attributes we sent and events we sent would be visible for whoever sent the message in the first place, so he can analyze those. Yeah, so what we now return is OK over response, and now it should be working. Yeah, there are no more compiler errors, but yeah, this is a handler for the first join message. Yeah, and it sends some replies message. Yeah, some sub message, some instantiate message. And what now we do need to do, we need a handler for handling the response, right? So let's create one. And this is handler for the reply. So what we need, obviously we need the smooth because we use affected blockchain. And we need some thing called sub message result. This is what I would use here. So yeah, what do I do? First of all, I need to know if the message failed or it was okay, and it is, yeah, it's not the easiest, the nicest thing to do, but what we first do, we just do it into result. It would make it into standard result type. I mean, there are reasons it's not already a standard type, but we do not go into details. So if it was okay, then we have response. If it was an error, what we get there, we got just a string representation from an error. But what you want to send is this std error, so we need to just wrap it with std error. Yeah, again, there's a really funny thing that we really cannot use the explanation mark here, and it is because we cannot create generic error just, the std error just from string with this. There is no proper into for that. Yeah, we need to do this way. Kind of a shame, but it's good enough. So what next? Next, we need to extract data from this response, because our data would contain the address, the new address of the created peer contract, right? So how do we do this? So the response, if we go into the sub message response thing, go into this, it is basically the error. If you go into submessage response, it contains events which are emitted. So events are those things with attributes, and data. And this data thing, in case of instantiation, is some magic structure which you know contains all information about instantiation. While execution, we can set data to anything we want. And yeah, those events, you probably noticed that before we set just attributes directly on response, but here are those events with attributes. So if we send something directly to response, it is using the default WASM event. And so we can attach as many attributes on default event we want. If you want, we can also add new attributes, new events. We will not do that today, but it's really simple. Just go to the response API documentation. So what do? We get this data, and yeah, if it's something, then it's okay. Otherwise, it's generic error with okay, it's no data. Let's keep it this way. Now, what we need is we need to convert this data to the proper instantiate response, and you'd use here the pass instantiate response data from the CosmWasm utilities crate, right? So yeah, basically we don't want to analyze this response by ourselves. This is some I think this Google thing, protobuf formatted message. We don't want to deserialize it by hand. We just use the utility library, and it returns some kind of error. We need to map it to our pseudo. Normally we would probably create some error variant for that, but we are not going into error handling. So how would you do that? It would be error error generic error R2. It's nasty way of doing that, but good enough for us. Close this so you can see the whole context. All right. Sorry for that. Now we'll add our address. So our address. So is our peer, sorry, here, and it's address unchecked, and you can see that I am not using validate as before. I use address uncheck. Don't I have address here? Okay, don't have an address here. Address unchecked function, which assumes that address I got is actually a proper address and it doesn't validate it. And it's good enough in our case, just because something is wrong. Just because, I mean, we know that this is the address we got from instantiation. Address. Right. Yeah. And what we need is the owner address, right? And we stored it before. And we just know that nothing happens since we last used it, so we just, you know, we can easily load it. And as last step, we do members save. So we just save in the storage this for this here. We store this address in the map. Okay. Okay. And now we just we can emit additional some additional for example attributes here or something, but why not? Actually, why not? I thought I would do that because I don't want to add any queries right now, so I need, you know, the way for whoever created this, whoever joined, to have his. So action join, I would go action joint owner. I would go with this, that this is the address, and I would have add attribute here. So I know the peer address, which is here as yeah, I would do that so it's easier later to use this. Okay, it's mostly for logging purpose, but you could use this way. Actually, in most cases, I would personally prefer to create a proper structure with those things and keep it as a data thing instead of attributes, because those owner and peer are okay. I would still keep it as attributes, but this is logging. This is not like actual thing I would use in contract, because it's, I mean, not so easy to extract those data from the call. But if I would want to use it from the other contract or from other contexts, I would like this to be properly structured, and I would, because of that, I would put it in this data thing. But it's kind of out of scope of this thing today. So yeah, we are you know, our time is ticking, and I need to, you know, finish it soon. So let me go to our library thing. And let me create our entry points. But this time, let me open those I created before, just, you know, to have something to look at. But instead of going this way, I would show you some other way you can disable thing for the feature array. And this is something I actually prefer. It's rarely used, but you can do it. I would create a public module. I would call it entry points. And here I would just do like, I like it because it also doesn't block my binary with those entry point functions if I don't want them. But you know, it's not always the best way. Is that okay? So it's entry point. I need to use CosmWasm stud entry point. Cosmos. Just importing stuff. Okay. That's all I need. With the instantiate. Oh, I created instantiate, but actually I don't have instantiate here yet, I guess. So yeah, instantiate. You can do it yourself. It's kind of trivial. Very similar to how we instantiate the other contract. But let me create another entry point. Exec. Yeah, so Why it's not building? Tell me. Yeah, it's all building. Like expected item, but I don't know why it complains. Go to maybe manager. It works. It works here. Yeah. And what I need additionally to do this, if I do it this way, I need to do this. Use entry points. Yeah. Okay. Entry points. Okay, so we are, I think, out of time. I really wanted to show you how to implement the distribution message. So I may do this because I don't know. If we need to finish right now, then thank you for attendance and see ya later somewhere in the world. But yeah, now you can cut off the video. But if you want to wait another maybe up to 10 minutes, I would like to try to implement the distribution message to show you a bit of querying, right? So how would I do this? I would go to my contract. Oh, sorry, do not break it. I completely forgot about the very important stuff. I need another entry point, which is pubfn reply, and how it looks like. Okay, let me open it. So I will not mess it up. It's like this, except I don't have this message info argument, and my message is of type reply. It's not message reply. It's Cosmos to reply. It's like this. So what do I do with that? I need to match on my message ID. So in my reply, if I go to it, for some reason, okay, this. Okay, and I go to this. I have this ID. I sent this message, and I have a result. And result is something we used before, but here I need this ID matched on this, and I just match on contract per instantiated ID. If it's that, I call contract per instantiate. Yeah, basically exactly what I wanted here. I will show you. Oh, okay. Constant is probably not public. In exec, I guess. This. Right. So now you can break the video. Thank you for attendance. And if we still have 10 minutes of time, I would proceed with this distribution message on this this last manager contract. Just to have some fun. Let me. So I would do this. I would go to this, create this public function donate function. And what do I do here? this. First of all, I need to query for my weights, and I have two ways to do that. First of all, I need to go. I can go. I can go to members. I can iterate to them to the keys. The storage. Here I send some boundaries for my, and I need my order. Doesn't matter which I use. Okay, so I go to the keys and I map them. How do I map them? First of all, here could be an error in case of some reading errors. Keys. Okay, wait a minute. Now I would do this. Donate. Okay, let's say response is donator's response from my other contract. And what I do here, I use depths. In depths is this query thing, and then I can query wasm smart, which queries the contract I give here. So what would be a contract? It would be up here. And here what I would do is here query, I would need to add it here. Instantiate query as here query. So this is the one way. Here query donators. So this is one way to do that. And this way is very much okay. I would do this here. Donations response donators. So I have them. It should be like this. Okay, this is just for calculations on those guys. Yeah, it should work. And I need to collect that to vector, I guess. Collect to stud result, because it may fail, and then I go to the okay, it's response. Okay. So this is one way to do this. So I just do query for every peer for the donators, but this is better way, which is it is better because it's more efficient. This way requires this message to be serialized and deserialized every time. It costs gas. But if I go to my peer contract, I would make my state public here. Now what I can do let donations. Sorry, donators to be done like donators from peer state donators dot. It's like query. Yeah, query here. So I query external donators map using depth storage, and here I use the address of the contract, right? If I do here this, so this thing is easier actually to read. You do not need to create your message. Here is address. Okay, instead of doing that, I need to do that. Oh, that's why I use. Okay, so I would not remove that because I want to use it later. So I want to do. I would clone this and not storage, but query or not by borrow. Nice. And now I don't need this thing. Way easier to read to me. Here I just need donators. Yeah, and way more efficient to work with because I never need to I never need to serialize any messages as before. And the rest one of this donation is actually not so complicated. I need to calculate total. So let total is being weights dot iter. I would ignore the second thing and I just sum this. So this is trivial. And what I need now, why is it complaining? Because it's full. What I need now, I actually need to know how much funds I have on my account, so I will distribute them. So what I would do, I would go funds, depth, query. I query the funds with query. I query all funds, all balances, so it would give me back all the tokens I have stored on the blockchain. I need to send the address. It doesn't give me my balances, but some balances. So I am using this environment thing with my to get my contract address. So this address of myself, and it may fail. And what I need to do now, I need to send message to all the receivers of the donation. And this is bad way of doing that, by the way, because it requires me to send as many messages as I have peer contracts. And if there are many peer contracts but costly, you do want to avoid them. There are many ways to distribute funds. For example, the CW 2222. You can go to Cosmos Plus, there is this contract and analyze that. But for now, it is just for demonstration purposes. This is the easiest way to distribute. So what I would do is, here I would just create the send messages. I would just iterate in Chuven. I would map them like wait, like this, I think. Okay, and I am doing like this. So my coins is vector. So what coins are coins which I'm sending. I need my funds, funds which I have all my funds. Iterate and what I do is that I need to clone them for because I mean yeah I need them cloned basically probably. Yeah, that's the easiest way. And now what I do, I map them because I need to calculate this very peer part. So I get this thing like this. Amount razy times, sorry, Polish thing. Amount times weight divided by total. And now funny thing here, I completely don't need to care about what happens if it's not an equal division. Everything is rounded down here, and if something is not equally divisible here, it would be just left on the contract and distributed later. It's good enough for us. For now, it's not always the best option. Why is this? Okay, that's why. Right? I have my coins, I need to collect them to the vector. And now I am creating bank message. Is just like WASM message, but this is to the bank, so it tells me to send tokens to what from the sender, always from the sender to what address. This time it's to peer. And how much of them is coins? would send all those tokens. It's not clones, it's clone. Okay. Why it dislikes me? Because the types doesn't match. Okay, yeah. We int type. This type is a Cosmos wrapper to allow proper serializations of big types, because JSON actually doesn't support this big types, like 128 types. So we need our wrappers to properly store them. And then when we have this, we just create a response. This is actually easy right now. I add messages, and it's nice function because I never needed to collect those. I just can pass an iterator. So handy thing. I would add my attribute action donate. I probably can even what I'm doing. Sender. Right. That would be useful one. No. Who is the sender? Info senders. I can send it. What I do, I just right. So this is my donate implementation. Now I go to my entry points, my dispatch. I need env here, I guess. Yeah, because I am reading this contract address. Yeah, leaf is not implemented, so I still want this. Okay, so that's everything for this workshop, because no, we were time limited. I think I covered most things I wanted to cover. One very important thing I had no time for, but sorry for that, is testing. But this is something you can read in my book. This is actually covered. Communication during contracts, it's not yet covered, but testing is covered in the book. You have testing a query, and then in execution messages we also write some tests. So you can go through that. In general, to test smart contracts, we are using this crate we call multitest. I really encourage you to go to documentation and take a look how to test contracts with that. But for today, really sorry I couldn't be with you there. And yeah, thank you for attendance, and see you somewhere in the future. Bye.